I am Dr. J.Arockia, ARULDOSS, Assistant Professor, PG and Research Department of Mathematics. Now we are going to see some definitions and theorems in the topic trace and transpose for BSc Mathematics final year students. First we see the definition of trace. The trace of A is the sum of the elements on the main diagonal of A. The trace of A is denoted by trace A, and if A equal to alpha ij, then trace A equal to summation I is equal to 1 to n alpha I. Using that, we see the definition lemma 681. For A comma B belongs to F1 and lambda belongs to F, we have three cases to prove. First one is trace of lambda A equal to lambda into trace A. Trace of A plus B equal to trace A plus trace B, and trace AB equal to trace BA. Coming to the proof, if A equal to alpha ij and then lambda A equal to lambda alpha ij, so that trace of lambda A equal to summation I is equal to 1 to n lambda alpha II, which is since lambda is a constant, we can take it out from the summation, which is equal to lambda into summation I is equal to 1 to n alpha II, which is equal to lambda trace A. So the first case is over. Now second one, if A equal to beta ij, then A plus B equal to alpha ij plus beta ij. Now taking trace for this A plus B, that is trace of A plus B equal to summation I is equal to 1 to n alpha II plus beta II. Trace of A plus B equal to, we can apply the summation for alpha II and beta II separately, which is equal to summation I is equal to 1 to n alpha I plus summation I is equal to 1 to n beta II, which is equal to trace of A plus trace of B. Therefore, trace of A plus B equal to trace A plus trace B. And finally, if AB equal to gamma ij, where by using the previous part, A equal to alpha ij and beta equal to beta, B equal to beta ij. Combining this AB, we get a new matrix, namely gamma ij, where gamma ij equal to summation k equal to 1 to n alpha ik into beta kj, and BA equal to mu ij, where mu ij equal to k equal to 1 to n beta ik into k, alpha kj. Thus, trace of AB equal to summation I is equal to 1 to n gamma II, and that is equal to summation I is equal to 1 to n and summation k equal to 1 to n alpha ik and beta ki. By interchanging the order of the summation, we get trace of AB equal to summation k is equal to 1 to n, I is equal to 1 to n alpha ik and beta ki. That is equal to summation k equal to 1 to n, summation I is equal to 1 to n beta ki alpha ik equal to summation k equal to 1 to n mu kk is equal to trace BA. Therefore, trace of AB equal to trace of BA. Next we see lemma 684, which is Jacob's lemma. The statement is, if f is of characteristic 0 and if s and t in A of V are such that st equal to ts is nilpotent. So we have to prove st minus ts is nilpotent. For any k greater than or equal to 1, we define st minus ts the whole power k. Now st minus ts the whole power k equal to st minus ts the whole power k minus 1 into st minus ts. That is equal to st minus ts k minus 1 st minus of st minus ts k minus 1 ts. Since st minus ts is commutes with s, st minus ts k power k minus 1 into st equal to s into st minus ts power k minus 1 into t. We consider this b as st minus ts power k minus 1 into t. Therefore, st minus ts whole power k equal to sb minus bs. Hence, trace of st minus ts the whole power k equal to trace of sb minus bs equal to trace of sb minus trace of bs equal to 0. By previous lemma, we get st minus ts must be nilpotent. And now we see the definition. Transpose. If A equal to alpha ij belongs to Fn, then the transpose of A written as A dash is the matrix A dash equal to gamma ij, where gamma ij equal to alpha ji for each I and j. Using that, we see a lemma for all a comma b belongs to Fn. A dash the whole dash equal to a plus b the whole dash equal to a dash plus b dash, and ab the whole dash equal to b dash a dash. Proof. As we know, a and b are a matrix. Let a equal to alpha ij, then lambda a equal to lambda into alpha ij. Now, the ijth element of lambda a is equal to the jth element of the lambda a dash, which is equal to lambda alpha ji is equal to lambda jth element of a is equal to lambda into ijth element of a dash is equal to ijth element of lambda a dash for each I and j. Hence, lambda a the whole dash equal to lambda a dash. Then the I plus jth element of a dash the whole dash equal to jth element of a dash, which is equal to ijth element of a for each I and j. Hence, a dash the whole dash equal to a. If a equal to alpha ij and b equal to beta ij, then we go for the third one.